Welcome back. Let us discuss part B of this 3-bit multiplier using gate level modeling. So as discussed in the part 1 of this, so we have to implement all this, like this is AND gate here and these are the AND gates. So let us implement that. So to implement that, we have to click this one, Model Sim Intel FPGA, double click that. And here I'm closing this and going to File, New Project. And this will prompt like earlier, one project is already open. Want to close? Yes, we want to close. Now this will come. Here you have to give project name. So let us give the project name, that is multiplier 3-bit. And this project location is important. Browse. On my desktop, I have created one folder, that is this lab demos. So I'm going to that folder. Don't select that folder. Inside that folder, create another folder with the same name, project name, multiplier 3-bit. Select that folder. And then these two default leave as it is. Click OK. Now you can create here file using this one. This method I will show in this video. Here, if you click create file, it will ask you like this. So give the name here. So I'm giving the same name, multiplier 3-bit. And here, don't forget, add file as type. So drop down menu is there, this one. Click there, select the Verilog. Don't select system Verilog or VHDL or any other here. Select Verilog. Here, Verilog. Here, you only have to give the file name. Okay, click OK. So now that file will be added to the project. Earlier, we are creating the file, saving, and then adding, right? Now it is been added here. Now I need test bench file also. So create file. So test bench file name is tb underscore multiplier 3-bit. tb underscore multiplier 3-bit. Again, here, don't forget this Verilog. Okay, so Verilog you have to choose. Now click OK. So we have design file, we have test bench file. Now you can close this one. Add items to the project, you can close. Now double click on this file, that is multiplier 3-bit. The editor will open here. This is the editor. And test bench file also you double click. So you can see the tabs here, bottom here. So this is design file, and here this one is a test bench file. So let us develop the design first. To develop the design, we have to start with the module and module name. Module name is multiplier 3-bit. Open the parenthesis, and this needs to be terminated with a semicolon. Now, if you look at this one here, we have A, B, this two operands, A operand and B operand. And the size of this these operands are 3. So if you look at the product output here, we have P0 to P5, right? So it means total 6 bits. P0 to P5 total 6 bits. So now what we do here, A is one operand, B is another operand, and product is another operand. I mean, output is another result that is coming out. So now input 3-bit, right? So it means 2:0 A and B also 3-bit. So comma B. Now output 6 bits, right? 5:0. That is P product. Now, if you look at this diagram, yeah. So to get this P0 and P1, so see how we are doing. To get this P0, we are ANDing this A0 with the B0. So let's do that. To get P0, I am creating total 5, 0 to 5. That is total 6. Why? P0, comma, P1, comma, P2, comma, P3, comma, P4, comma, P5. So like that, total 6 variables to hold this result. This result P0, P1, P2, P3, P4, P5 further. So now, so let us proceed. We can use assign keyword to get the P0. P0. So how we get this P0? How we get this P0? By ANDing these two. So what is the AND operator? Ampersand, right? So that is A of 0 ampersand, that is for AND operation, B of 0. Put the semicolon. So you have done this one. That is A of 0, B of 0. You have assigned to P0. Now you have to take A of 1, B of 0, assigned to Y0. Okay. Now you take A of 0, B of 1, assigned to Y1. Let us do that. Assign to Y1. Here, Y0 first. To Y0. So what we are assigning to Y0? A of 1. A of 1 ampersand B of 0. Semicolon. Now next, assign Y1 equal to, here if you look at this Y1, A of 0, B of 1. A of 0 ampersand B of 1. Semicolon. Now what we have to do here? This A of Y0 and Y1, what we have to do? We have to add them. So if you add this, you will get sum as a P1 and carry out will go to the next stage. So to add this, what we can do? We can use assign, that is to, this is sum, right? Sum, how do you obtain? By using XOR gate. So P1 is obtained. P1 is obtained by XORing Y0, by XORing Y0. XOR operator is this one. So Y0 and then Y1, semicolon. Now, how do we get the carry? That is C1, Y0 ampersand Y1. That's how we get the carry, right? So this part is done. This part. Adding this two, that is using XOR gate, got the sum that is assigned to P1, and carry also it will produce. So Y0, Y1 like added. So because we know the half adder, here half adder is required. Half adder is one XOR gate, one XOR gate, and one AND gate. This XOR gate will produce the sum, right? And this will produce the carry. So that is what we have done there. So carry out is going to the next stage. We will use that C1 that generated in the next stage. But for now, we have to generate this A of 2, B of 0 A of 1, B of 1, A of 0, B of, and we had to assign two variables y2, y3, y4. So let us do that y2, y3, y4. Assign here to y2 we have to assign, and just copy this portion. Control C, then Control V, Control V. So this is y3 and this is y4. So if you look at this one, this is y2, y3, y4. So to y2, A of 2, B of 0. That is A of 2 ampersand B of 0 semicolon. Now y3, how we are getting y3? A of 1, B of 1. So A of 1% B of 1 semicolon. Now how we are getting y4? A of 0, B of 2. A of 0 ampersand B of 2. Now what we have to do, we are ready with this y2, y3, y4. Okay. So when we are ready with that, what we have to do is we have to add this, C1 with y2, y3. So here three variables are there. Three variables are there means what we can use? We can use full add. So full adder expression we know already. So somehow we can get A XOR B XOR C in, right? That is the Boolean expression for full adder. And carry out how we get A ampersand B, and that is ORed with A ampersand C in. Ampersand means you are ANDing the AND operation. That is ORed with B ampersand C in. That is the Boolean expression. So same thing we are going to do. Instead of A, B, C in, what we have here, C1, Y2, Y3 we have. So we need other two variables here to hold this sum and CO. So let us do that now. Assign. So the other two variables, let us call it as a S1. Ensure that that variable not been used previously here in this code. So S1. To that S1, what we are going to give the C1 XORed with Y2 XORed with Y3. That is done. That is for sum. And assign. Here carry notation I already have given. That is C2 I am calling here, C2. So let us call C2. C2. Now here C1 needs to be AND operation needs to be done. C1 AND operation with the Y2 and then vertical bar. That is OR operation. Again, C1 AND operation with the Y3. Again, this OR operation. Now Y2 AND operation with the Y3. So that will produce us a C2, that is carry out. Now what we have to do, we got the sum here, right? This sum by adding C1, Y2, Y3, we got the sum. So that sum needs to be added with this Y4. So it means only half adder is required this way. So the sum one, S1 is XORed with the Y4 to get this P2. And when S1 you are performing AND operation with Y4, that will produce C3. Okay. So pause this video here if you have doubt. I repeat again. by adding C1, Y2, Y3, you got sum 1, right? That sum 1, S1 needs to be added with Y4. So only we need a half add. So S1 is XORed with Y4 to get this sum, that is P2. And when S1 is ANDed with this Y4 AND operation, then it will produce a carry, that is C. So let us do that. Here you pause and listen what I am saying. So let us go to that. Here, assign. That is this sum if I do, that is S1 if I add with this Y4 using XOR gate, then what I get is P2. So let us use the P2 directly here. P2. Here S1 XORed with the Y4. That is done. XOR operation. Now assign C3. This time this is C3. So how we are getting C3? C3. C3 is obtained S1 ANDing with the Y4. So that is done. Now what we have to do here, this section. In this section, we have to get this A2 B1 for ANDing. I mean by ANDing A2, A of 2 with the B of 1, we get Y5. And A of 1 with the B of 2, Y6. Let us put Y5, Y6, two variables. Sign Y5 and assign Y6. So now to Y of 5, Y5, what we are doing? A of 2, B of 1. So let us do that. A of 2 ANDed with the B of 1. Semicolon. Now Y6, how we are getting Y6? A of 1, B of 2. A of 1 and with the B of 2. Semicolon. So now you have got Y5, Y6. Now what we have to do here? Same thing again. C2, C3, Y5, we have to add this. We get the sum. Call that sum as a S2. And it will produce carry also. That carry is called as a C4. So let us do the first S2. So if you do the S2, assign S2 equal to, so S2 how we obtain? By adding C2, C3, Y5. C2, C3, C2, C3, Y5. So C2 XOR with the C3 and XOR with the Y5. Now we have to produce carry also. C2, C3, Y5. Now we have to produce the carry. The carry expression is already written. This is the carry expression. Instead of A, B, C in, we will have C2, C3, Y5. Okay. And that output is given to C4. So let us go to here, assign C4. So here, assign C4. Now what we have to do here, C2 and with the C3 and vertical bar, that is for OR operation. Now C2 and with the Wi-Fi. Again, close the parenthesis and vertical bar. Now what we have to do, C3 and Wi-Fi. C3 and with the C3 and with the Wi-Fi. So that will produce the carry. That is C4. Now this S2 here, that C2, C3, Wi-Fi we have added now, that will produce the S2. That S2 we have to add with the Y6. Meaning 2 bits we are adding means we have to use a half adder this way. So this half adder, what it produces a sum. That sum is a P3. So let us do that first P3. That is here P3. Assign P3 equal to P3 equal to here P3. How we are obtaining this S2 XOR with Y6. S2 S2 XOR with Y6. And that also producing a carry. So that carry name what we have given here, C4. So C4 equal to S2 and operation with the Y6. So that is done. Now come to this one. Now what we have to do is we have to produce this first A of 2, B of to get this Y7. So let us do that Y7 first. Assign Y7 equal to, so how we are getting A of 2 ampersand with the P of 2. So that is the AND operation to get this Y7. Once we got this Y7, we have 3 bits here, C4, C5, Y7. So what we have to do, we have to use this full adder Boolean expression. So the sum is directly going to P4. So C4, C5, Y7. If you perform the sum that is using XOR operation, it will produce P4. Let us do that. P4 assign P4 equal to P4 is how we are obtaining C4, C5, Y7. C4, C4 XOR with the C5 XOR with the Y7. So here this C4 is there, but we have to look at C5 in our code where it is. Here we have C4. Oh, here when we are doing this AND operation, we did AND operation here. Just let me check again where we missed that one. We have here the carry produced here in C1, C2, C3, C4, C5. So we are adding this, we have to add this Wi-Fi and in this process, when we are doing C2, C3's Wi-Fi addition, that is C4 we are producing here, C4. C4 already has come here, C4. So this supposed to be C5. Supposed to be C5. Okay, that is the update here. At line number 31 already we have C4. So this cannot be again C4. At line number 35 it cannot be again C4. So it is C5. So that is what here we are doing. Assign C4, C5, Y7. Now we have to get the carry from this stage. So the carry that we are getting from this stage is, here this stage is C6. But that C6 is actually directly given to P5. So what we can do directly, we can give it to P5 and produce the carry. So pause this, understand what I'm saying. We have added this C4, C5, Y7 and we got P4, right? So this is also producing a carry. Instead of saying C6, you can directly say P5. That is what my point is. Pause this video and understand here. So here, that is P5, I can produce the carry directly C4 ampersand with C5. This is OR operation. And then C4 AND operation with Y7. Again, OR operation. This time C5 AND operation with Y7. So this is simply what we are doing here. This one we are doing A ampersand B or then A ampersand C in, then OR operation, then B ampersand C in. That is nothing but in full adder design that carry expression, carry Boolean expression. Okay. Instead of A, B, C in, we have here C4, C5, Y7. That's all. This C4 ANDed with C5, OR operation, then C4 ANDed with this Y7, then again OR operation, then C5 ANDed with the Y7. So that will produce the P5. So you have done with your code. Now you can put AND module. So now this asterisk that you are seeing here and here also. So it means this file had to be saved. Click on save. This time the prompt will not come because we already added the files to created the files. We just edited those files. At the time of, creation of this project, it has prompted whether to create the files there where we have created these files. So files are already there. We edited them. We only have to save. Okay. So now let us develop the test bench file. To develop the test bench file, I told already, we have to, and one more point here. These variables that you see not declared, P0 to P5, okay, we have declared, but Y0, Y1, this C1, C2, you don't see them declared here. So no problem because they are scalar type. All scalar type are wire. So like wire, here, Y0, like that. Okay. So undeclared variables are treated as single bit wire or scalar wire. Okay. So them, if you are not declaring, them also no problem. If it is a vector, then you have to declare. But here we do not have any vector. Here all variables, undeclared variables are scalar only, 1 bit only. Scalar is 1 bit. So now go to the test bench. Before that, let's copy this. Go to test bench. Now here backcode time scale 1ns/1es and here module db underscore. The name here is multiplier 3-bit semicolon. Now paste this one, but here this instantiation is after this, variables. So put here and create the space here and call it as a DUT. Now this input is changed to reg and this output is changed to wire. Now you have this so you have this reg here, AB, wire, P, and the module that you wanted to test is this one. So now let us go to develop the inputs here. Initial, begin. This begin will have end, and module will have end module. So now here, what I have to do is at different time intervals, I have to give A, B. So to give that at different time intervals, what I'm going to do is I'm going to use my for loop and I'm going to write here I equal to 0 colon I less than I less than or equal to 7. Because with 3 bits, I can go up to 7 only. 2 power 3, that is 8. 8 means 0 to 7. And then semicolon. And then I equal to I plus 1. Now begin. Here what I am going to do is, I am going to use that one. A equal to dollar U random. That is unsigned random values, integer values. It is going to produce, but it is going to produce 32 bit. I don't need 32 bit. I need only 3 bit. So for that, what I have to do is I have to take the modulus, and with the 4 I have to divide. So same again, copy this, Control C and Control V here, but this time it is P. And now you put some delay. This is because at 0 simulation time, this will happen. When this loop iterates again, you are, keeping the delay. So after that delay, this new values will come. So like that, you can have the simulation time, like proceeding from 0 to some time interval. So for that, this delay is required. Now, once this all 7 values been produced, when we come out of this loop, so again I am giving #5 delay. There I am stopping my simulation. $stop. $stop is a system task which stops the simulation. Okay. So now see carefully whether all this begin and end is proper. This begin has got this end. This begin needs to be enclosed. So this is end. Now this is done. Test bench is done here. Save this one here. Now what we have to do is we have to compile this one. So just close this one. Now to compile this, go to compile and compile all. But here to print here in the console, I did not include here. So to include that, what we have to do after begin, dollar monitor, open the parenthesis, inside that double quote, inside double quote, @time. @time is for our reference only. That is not a keyword, that is not anything, but %G is a format specifier for time. This NS is for our reference, that is to print in nanoseconds like that, because this delay is in nanoseconds with the help of this compiler directive. So that's why we wanted to see like nanosecond. And then space A equal to %. So I wanted to print here in a decimal format. So %0D. B also I wanted to print in a decimal format. So %0D. And P also I wanted to print in a decimal format, that is a %0D. Now I have to correspond to this format specifiers. So I'm corresponding this $time, that is the system function which returns the simulation time. Then I will copy this APP, copy this and paste it here and close the parenthesis. This will help us to print in the console. Okay, save this file again. Now go to compile all. So it is saying some error here. Let us see what error it is. So how to read the error? Double click this error. One error is there on that, double click. So it will show up here. What it will show up? It will show up file name and the line number. So this is your file name and the line number is 12. What it is saying? Something undefined variable I. So the loop variable that we have used, that needs to be declared here. So that is integer I. Then semicolon. Save this file. Again compile all. So now no errors. So we got a tick mark here. So now go to simulate, start simulation. Now, as I told, locate where the work folder is. In my case, here it is. There is a plus sign, expand that. Select the test bench module name, click OK. So once that is done, you have to wait till you get this here. This is a SIM tab you must see here. So if you create little space here, you can see SIM window. Okay, this is the SIM tab and this is the SIM window title. So this you must see. So if you want to see in the waveform here, so in the waveform, then what you have to do is you have to add this one. So let me reset this. So to see here, what we have to do is we have to add here to the waveform window, add wave. Then these variables will be added to this waveform. So in case if you want to see, otherwise, since you have included the dollar monitor, it will be displayed here once you run this simulation. But here, this also you have to change to P2M nanoseconds because our scale is in nanoseconds. So run. So now you can see here this simulation time printed and some inputs are printed, but we are not getting this P output. This is because we did not assign in the design file. In the design file, if you look at here, we did not assign to P. We're supposed to be collecting all of this P0 like here discussed. So all of this here, we have to collect this P0, P1, P2, P3, P4, P5 and assign to product, right? So that we did not do here. So let us do that in the design file here. Assign to P. So we have to use concatenation operator, that is curly braces, curly brackets. So now P5 is a MSB, comma, P4, then P3, then P2, then you have P1, then you have P3. So these are the intermediate this product bits. So all of these product bits we are concatenating using this curly brackets or braces simply. So we are assigning it to actual product output. So now you save this file. Let us close this one. So save this file and then you compile it again. Compile all. So now you got this tick mark. Again, go to simulate, start simulation. From the work directory, this is directory means work folder. Expand this plus sign. Select your test bench module and click OK here. So if you do so, then, then in case if you want to see in the waveform, as I said, right click, add wave, because this will be added. So they've been added to waveform by right click and doing this add wave. Now ensure that here nanoseconds is the N is there, not P. Now simply run. So now if you look at this one here, in the waveform also, of course, you can check. I already discussed this one. Just click here and go to this zoom full. So like that, you will get place cursor anywhere here. Corresponding to this cursor time interval, here are the values. So you analyze them. But here, since I use the dollar monitor, I will check from here in the console. 2 into 2, that is 4. 2 into 3, 6. That is correct. 0 into 3, that is 0. 2 into 1, 2. 0 into 2, 0. So I'm getting the correct results. So that's how you are going to do this, your 3-bit multiplier. So to stop this simulation, go to simulate and end simulation. So it will say close this. Yes. So kindly pause this video, note it down in your notes, and the way it is here shown, you please practice this code in your system. In case if you have any issues, then you please discuss with you. Okay. All right.